All right, let's get started, I suppose. So today, I just wanted to do something different, something special, I suppose. I want to be able to include C files over HTTP. Hello, Aguduk. Hello, Ceremon. Hello, everyone who's watching right now. So yeah, we're gonna make it happen. We're gonna make it so the compiler, a C compiler, can include files over HTTP. So, you know, the long-awaited package manager in C, C++. So let's actually create a small example of what precisely I want to have. I want to be able to include such things as SBT's, you know, libraries. SBT, STB. It's more of a STB libraries. So I'm gonna put them in the description. So this is gonna be STB libs. You can find this thing in the description if you are interested in this kind of shite. And let me go. So we can just grab something. For instance, STB image. Okay, so let's actually grab the image, and this is a library that lets you parse images in different formats like PNG, TGA, BMP, PSD, Photoshop files, apparently, GIF, HDR, and some other shit that nobody uses. So yeah, essentially it's a single file, and you can simply just include it in your project. So let me see what we can do in here. I'm gonna just download this entire thing. Hello, Jacobs. All right. So, and let's include this entire thing. I'm gonna STB image, right? STB image.h, and we need to have S implementation, right? So it's quite important to have this thing in here. And I suppose we need to accept the path to an image somehow, maybe via command line arguments. So let's actually quickly do that. So we're going to include argc, char argv, and if argc is less than 2, right? If it's less than 2, that means you didn't provide enough arguments, right? So this is going to be a std error. Excuse me. Hello, that's pausing. So how are we going to call this thing? So let's call this STB image check, right? So this is going to be something like input. Yeah, this is just going to be the input. This is going to be the usage. All right, so this is the usage, and std error, error. No input file is provided. No input file is provided, and then we simply exit with non-zero exit code. And yeah, so that's how we're gonna provide all of that. So it's gonna be something like const char input file path. Hello, argv1. Alright. So what's the image that we're going to be using? I think we're going to be using something like Sodin W. That's actually even better. Let's use Sodin flushed. I absolutely love this emote. Dusty Powers, thank you so much for 10 months of subscription. I really appreciate it. Sodin flushed PNG. Alright, so here is Sodin flushed. And we're going to be using this for testing everything, right? So, load image, I think it's something like stbi load. Yeah, this is how we do all this stuff, right? This is how we do all that. So here are the variables x, y, and n. N is supposed to be the amount of components, right? So, but we don't really care about the amount of components. What we care is that the amount of components is exactly 4. And here we have pixels, right? So maybe we do care about the amount of components, why not? So I'm gonna actually put like n in here, this is gonna be 0, and let's print this kind of stuff. So file path is going to be s input file path. There we go. So then we're gonna have something like width, right? Let's actually align everything. I think it's gonna look good. So it's gonna be X. So then we're gonna have height, and then we're gonna have Y print, and I'm gonna call it comps, right? So this is the amount of components in the image, and then we're gonna just exit. So this is gonna be a very simple application, right? Which basically loads the image, prints its file path, the size of the image, and amount of components per pixel. So pretty straightforward, nothing special. So let's actually build this entire thing. I don't know, let's actually do it like this. This is going to be something like argv 0, but we're also assuming here that argc is at least equal to 1, so otherwise this is basically incorrect thing to have in here. Right, so let's see if it compiles. So I'm going to just see main.c input file path. There we go. Alright, so it uses math, apparently. Okay, so let's also link it with a mathematical library. Okay, cool. So now we have this kind of thing, and if I try to run it, it asks for the input, and then if we provide the input, it will tell you the file path, right? So the width and height and amount of components, and as you can see, it is correct. It is a standard Twitch emote 112 by 112. That's what it is. So, but here's an interesting thing. This is kind of boring, and it's not particularly modern. You know what I want to be able to do? I want to be able to do this shit like this. This is what I want. It's so fucking cool. My Emacs is incapable of even highlighting this properly. So I wonder if I can do something like what is it called? CC mode? Or maybe just C mode. Can C mode actually highlight that? Okay, C mode at least can highlight that, but it takes like half of an hour to actually start up. Right, so I want my compiler to basically query GitHub, download this file, place it somewhere, and include it like that without me doing all of that weird shit. So that's the goal of today's stream. So yeah. Okay, so let's actually put this like this. I just want this to be a thing. Alright, so let's put it like this. Cool. I just want this to be a thing. So essentially, yeah, it will just automatically download this stuff. And this kind of idea actually works really well with STB style libraries. I wonder if we can actually use like an arrow up, or maybe look at how to do that. It doesn't work. Okay, so this is going to be just this. Alright, so let's actually upload it somewhere. So this is going to be an explanation of what we're doing right now. So is it going to highlight properly? Even GitHub is incapable of highlighting it properly. So let's create a secret gist. No, it actually highlights it properly. I guess the editor cannot highlight it properly. Alright. Oh, and what's cool is that in GitHub you can actually refer not only to like a latest library, right? You can actually press Y. Look at this URL, right? You would see that it points to master. You can press Y and make this. Oh my god, why does it take so much time to load? Okay, you can press Y and your URL becomes the current commit, right? And you can take a raw version of the current commit, and you can, well, you can't do that apparently. GitHub. Okay, so now it gives me. So I can basically even depend on a specific hash. Not only on the latest one, but also on a specific hash. So did I create this already? Alright, so let me take a look. So this is the project. Update CMD, or it's going to be something like 1 sender. Yeah, I guess we're gonna just give the link to this file, and that should explain enough. If that doesn't explain anything to the viewer, that means they're watching a wrong stream. They should go watch some hot tub stream or whatever, right? So if that is not enough to explain, well, you're probably watching wrong stream. Sorry. It is what it is. Not trying to be a dick or anything, but it's just like, yeah, that should be enough to explain what the fuck we're doing. Okay, so right now it's not gonna compile for sure. GCC just simply does not support that. Right, main.c, right, and as you can see, it does not support that at all. I wonder if I can create like I don't know. Think if HTTP include, right, if HTTP include, do that, otherwise, else include stb image.h and if or something. Yeah, so is it gonna work? Is it gonna work? It's actually working. All right, so this is gonna be lm. This is going to be lm, and so we have a source code, and at any point I can just simply do define HTTP include, right, and it's going to simply work, right? So if def, it has to be if def. All right. So we need to actually hack an existing C compiler, and I was thinking, what C compiler can we use? We could probably use GCC. And GCC, as far as I know, C preprocessor is a separate executable, but I think it would be way easier to actually hack TCC, right? Because it's so simple, and yeah, it's actually TCC is actually perfect for different experimentation, I would say, right? For different kinds of experimentation. So we're gonna go with TCC today, and we're gonna try to make TCC include files over HTTP. So yeah, because it's small, fast, and unlimited, whatever that's supposed to mean. Is your compiler unlimited? Sfus. The compiler is Sfus. Not gonna lie. Very Sfus compiler. Sus. Sfus compiler. Alright, so where can I download this shit? Okay, so here is the download button. Le button. So which version should we use? I suppose we should use the latest one. This is a TCC BusyBox. They haven't released... Is the compiler dead? It feels like it's dead. Maybe it is dead. Yeah, it is dead. Stable release. Is it active? Departure from F distribute patches summon forks. Oh, okay, so I suppose it is. Yeah, official active discussion developed by media interested. Announced on the main TCC. Okay, so. Alright, so it's like semi-active. Semi-active, but maybe it's fine. So the only thing I care about is whether I can compile my example with TCC. Why do I have all these images in here? What the fuck is wrong with me? Alright, so... That's a folder of a professional memer right there. Okay. So I'm gonna just download this thing. I should have actually downloaded it with ampersand, if you know what I'm talking about. Alright, so maybe let's put like a folder sample, right? And we'll remove all of that stuff into the sample, right? And this one is going to be tar fvx tcc. All right. So what do we need to do in here? Let me actually just run configure. Wait, this is not autoconf or something? This is a really strange autoconf, to be fair. Oh. Okay, so this looks like a custom configure script. It's not an autoconf or any of this bullshit. This is actually nice. I really like that. It still has this concept of, you know, prefixes, I suppose. Does it have this concept? Let's actually take a look at the help. Do you have that? Yeah, it's sort of like, it's not really autoconf, but it tries to mimic autoconf. This is actually nice. So can I do something like distribution, right? So a separate folder, and just say that I want to do prefix into the distribution, right, in here. Oh yeah, I can do that. All right. So, and if I try to build this entire thing, what's gonna happen? So it's building shit. I wonder how long it's gonna build. Warnings? What the fuck? Why do you have warnings in your compiler? How can I trust a compiler with warnings? Alright, so it finished with 0 exit code, and so I suppose we need to do something like make install, right? So this is going to be make install, and there you go. So here is the TCC compiler. How about that? Isn't that amazing? I think it's goddamn fucking amazing, mate. Look at that. It's LF64-bit LSB Pi executable. I love pies. My god. Dynamically linked. Disgusting. Disgusting dynamically linked executable. What does it depend on? Does it depend on half of my operating system? Wait a second. LDD TCC. Right. So it depends only on, like, yeah, mathematical library, libc, and yeah, it's fine, I guess. It's fine. Not that much. Not that much. Acceptable, I would say. It's pretty acceptable. So let me see if I can compile my sample using TCC, if you know what I mean. So yeah, we're not gonna do that, and what essentially I'm gonna be doing, I'm gonna be going to here, TCC, distribution, TCC. Maybe it would be better to actually put distribution folder up there, but I'm not sure, maybe. TCC, distribution, bin, TCC, and main.c, and std-def is not found. Interesting. No std.io. So when it's trying to include this thing in here. Alright, so can we try to maybe define no std.io then? stb no std.io. So maybe that will do the trick. And it didn't do the trick. That's really strange. No, it still includes... This is kind of strange. Can it even compile like a simple hello world? Is that even possible? Is that even a thing that you can do? Because I remember actually being able to compile hello world using TCC, but now I'm incapable of doing that for some reason. That's really strange, if you know what I'm talking about. The compiler that cannot compile a hello world. That is kind of such. Truly such. Hello. No, it cannot do that. Oh wait, maybe it's actually looking for shit inside of the current. Okay, so I think I'm realizing what's going on in here. So what if I try to do something like this? What if it's going to be distribution, and this one is going to be something like sample main C. It's actually not main C, but hello C. Yeah, I was right. Okay, so it was actually looking for includes in here, which is rather interesting because I would expect it to actually... It didn't even install its own shit. Huh, that's really interesting. So it installed only libtcc, but it didn't install the actual includes that are in here. That is really sus, not gonna lie. Oh, and here is the std-def, by the way. Here is the std-def. It literally didn't install that. Okay, so that's really sus, not gonna lie. What about hello in here? And yeah, here's hello. Okay. So let me see. So this one is gonna be something like dist bin TCC. So I think I'm supposed to actually run it from this folder now. Thank you, TCC. Very cool. This is gonna be main, and this is gonna be something like main. All right. Oh, this one is interesting. So intrinsic, MMM intrinsic. So I wonder how difficult would it be to actually compile this entire stuff using TCC. So let's go ahead and disable some of the stuff, right? So yep. So we have std out. To be fair, maybe we don't even need this stuff anymore. So it's gonna be just that. And TCC is gonna be something like that. And undefined symbol POW. Alright, this is understandable, so maybe I need to include math before trying to include anything else. So let's actually include math.h, which is kind of strange. Undefined symbol POW. Really, even if I try to include math, it didn't have POW. That is really strange. That is really sus, I would even say. Does it have a math? Probably not. Can we actually use some of the headers from GCC? Do you need LM? But it says undefined symbol. Is it the error of the linker? Because it looks like an error of the compiler. Right. So, okay, I can try to do LM, but this is... Oh, okay. It literally looked, for some reason... Because I got used to the GCC saying that undefined reference to something, so if I don't see the word reference, I automatically assume that this is not a linker error, and that means it cannot see that on the level of the... Yeah, Stockholm, I suppose. Well, yeah, when you're using one compiler for a long time, you kind of get used to its errors, and this becomes like really not obvious. Even though this error message does make sense, right? Because if you're talking about symbols, you're probably talking about symbols in terms of linking, right? So, I guess. Alrighty. So, and can I now do something like main and sample Tsodin flushed, right? And it's working. Okay, the thing that compiled with TCC is actually working, so that's pretty cool. I'm really happy. So what about now if I try to include HTTP include, right? So HTTP include, and I'm gonna just try to run this entire thing, and yeah, include file not found. Nice. It actually tried to include this thing, but then it couldn't find it. All right, so can I, by the way, literally just go here and grab this error message and just do something like grep rn include file. So maybe I'm gonna actually, you know, put some stuff in here. So this is gonna be a regular expression. Do we have not found? Okay, so there's only a single place in the entire compiler where this combination of characters is actually used, and here it is. So what do we have in here? Include file was not found, so this is some sort of a loop. This is how easy you can find a precise place in any application that you want, right? So essentially you're trying to hack some application, it prints some messages, you just grab the messages in the source code and you already found the place. You already fucking found the place. So, all right, TCC couldn't open. So let's take a look. So we have some sort of there's a lot of go-tos in here. I suppose they're using some sort of like a state machine and they jump between the states. Okay, so here's the file name. We allocate the buffer of that particular file. So this is checking for absolute path. Searching for that and that. So search cached include, so some of them can be cached. That's pretty cool. TCC open. TCC open. This is very, very interesting. TCC open. You know what? I have an interesting idea. what if I try to find all of the files that end with H and C? Right, so here are all of the files that end with H and C, which is supposedly, I think, the entire code base of TCC. Right, and if I try to put them into E tags, right, if I try to put them into E tags, I'm gonna have a tags file for the entire source code. Here's everything. Okay, so... Oh, we're even literally in a file called TCPP. This is actually beautiful. I absolutely loved Tiny C compiler. It's actually a shame that it's not really that actively developed anymore, because it's absolutely beautiful. It's so easy to navigate, right? It's so easy to navigate. I just instantly found the place where you handle includes, like, what the fuck? Can your GCC code base do that? Or can your Clang code base do that? Can you just grab the source code of your project and instantly find the place where you need to make changes? Yeah. I'm pretty sure you have to wait half of a day just to build the goddamn thing. Anyway, so... But there's not platforms, optimization. Yeah, sure. Okay. So here's the TCC open. File name, that's actually pretty interesting. So, oh, you can actually have like a dash as a file name, and this is going to be like a standard input. Okay, that's pretty cool. So you can also open a file and so maybe this is where we have to just basically make a query. Hi Simon, hi. So I actually want to do something. Can we just print this goddamn file? So it's gonna be something like this. Print f file path is gonna be s file, not field, file name. There we go. All right. Can I rebuild this entire shite? So there's a couple of warnings in here. Mixed declaration. Oh. It's a C90 code. What the fuck? I mean, it built actually successfully. I suppose I need to put this thing in here. I mean, it's not that big of a deal. Just like you put all the variable declarations at top. So it's fine. It's totally fine. Nothing special. All right. So what if I try to build my simple project now? How do I build it? Oh yeah, I forgot to. Didn't I rebuild everything? I need to install it. Yeah. I need to install it. I need to copy it into the dist. Okay. I completely forgot about that. I probably need to do it like that. So I need to do make and then make install. All right. So if I try to do this kind of thing, so what do we get? Here are all the files that it actually included. The fuck? Why is it so easy to just find a place in the compiler and just start hacking it? Like, this is disgustingly fucking easy. I hate it. Where is the pain? Where is the... And wait. Oh, this is actually really fun. Look at the file it was trying to include. Look at the file. Look at this dude. Look at this dude. Alright, so it was trying to... find this particular thing in all of these different places. This is actually pretty cool. I'm sorry. So this is pretty interesting. I'm not gonna lie. How does properly will circuit in curl? I don't think so. I think with the curl, we're going to be literally just download the file to the hard drive and just open that file the standard TCC way, right? Maybe via TCC open, right? So I don't think we need to hack the reading process too much. It's just like when you try to include, we start the curl thingy, we download it somewhere, we maybe even caching it somewhere, and then just continue as usual. Just continue, you know, executing as usual. I don't think it's gonna be that hard. We'll see. We'll see how it goes. I'm not gonna try to overcomplicate this thing. So this is gonna be TPP. I suppose this is where it's trying all of these different things, right? This is where it's trying all that. TCC open, right? So let me actually move this thing in here. So this is the buffer, buffer 1. So if it starts with this thing, wait a second, can I do something like if starts with, right, so, and what is n? So we're iterating all of the include paths. That's what we're doing. We're including all of the paths. So if this thing is not absolute path, we just continue. If it starts with this thing, we're searching for that file. If it starts, if it doesn't start with this thing. This is very interesting. What if I try to include my thing with quotes in here? Can we try to do that? It didn't really change that much. So I want to somehow get the raw HTTP thingy. I want to somehow get the raw HTTP thingy. So this is where we started to check for this path, and yeah. Caution to deep. Let's expect file path or file name. Okay, we can try to do that. What I want to do in here, by the way, I want to check that the path starts with something like HTTP // So if it starts with that, we can try to deviate from the normal process of this entire thing, make, for instance, HTTP query, and yep. Interestingly, it just continues. Disgusting sound. So what I understand about this loop, this entire loop is basically searching in different include paths. Right. So we can actually try to go to the end after we detected that this is a HTTP. Right, and in the end, yeah, okay. Alright, that's actually pretty cool. So this is really convenient. So you can check several things. You can, for instance, open a particular file and then go to the end. Makes sense to me, actually makes sense to me. Alright. So, can I do something like printf? So I want to actually just distinguish it from whatever I have in there. Right, so this is going to be something like buffer. All right. So TCC open. So did I remove that from there? I think I did. Oh shit! I just realized that I would like to have an ability to see the diff between my changes and the current changes. Maybe I should actually grab the source code from the official Git repo. or maybe some other repo. That would be actually kind of cool. Tiny cc git repo. Let's actually do it like that. So is that the official repo? TinyC, an official mirror of mob development. So what's the official place for TinyC development? TinyC. I need to take a look at the Wikipedia. It looks like maybe there's a shit ton of forks and stuff like that. Download. It's a Git hosting website. The fuck is our... Excuse me. This is sus. Why would you host shit on such a sus website? Don't understand. People are weird. Hosting shit on sus websites. So URL, let's actually try to text this thing. Okay, so we're gonna do git clone, and let's see. So that was a bad idea. Should have actually done that slightly differently. Git clone, and yeah, there we go. So here's TinyC, fuck that, we don't need that shit anymore. Okay, so mob, what the hell is mob? It's just confusing, like what are you guys doing there? Oh my god, mob. Like I never understood this like separate branches, like there's a master branch, there's like a development branch, and people have weird like git flow shit. Come on, just fucking develop. Just develop the shit. It's that simple. Don't overcomplicate the process. Alright, so I wanna actually go to like a very specific thing. Create checkout, well, I wanna create checkout in here. Yeah, I wanna check out this thing. Okay, cool. So, and, yep. Maybe I need to actually create a folder, make dir dist, right, there we go. And we're gonna do configure, right, so, and just do configure prefix dist, there we go. So, pretty cool. Can I do something like with 5 threads? Okay, so if I do something like make install, right, so make install, and let's see what we have in here, right, and the reason why I wanted to have all of that, so what was the file? TCCPP, so talk include, was it? Yeah, it was include, right, so if I make any changes in here, right, so printf, maybe I'm gonna replace this thing, there we go. Alright, so this is going to be buff, alright, yes, and now, yeah, so this is precisely why I wanted to have that. So if I make any changes, I want to see what kind of changes I made relative to the current release, right? So that's precisely why I was doing all of that. I need to make the music a little bit louder. Okay, so I also need to do actually make install, I think. So, and then we're gonna do dist bin tcc o main sample main.c, and I think we also need to do lm, right? So is it gonna work? Is it gonna work now? Yo, yes, we found it. So this is basically where it's going on, right? You see, we got the actual string of the URL. Now we need to check if it starts with a particular string. Right, how can we easily check that? Is there something like str ncmp, or maybe man strcmp? Strcmp requires like null terminator or something. Similar accepted compares only first n bytes of s at most. It probably also takes into account some other stuff. So let's do something like this, main.c. So we're gonna have a special string, right? Const char s, and what we're gonna do in here, it's gonna be something like stdio, stdlib, math. So if strcmp I swear to God, one day I'm gonna go to the source code of Emacs, I'm gonna find, git blame who made the change to actually pop up the dialog. I'm gonna find that person. I'm gonna find that person. And I'm gonna tell them everything I think about them. You guys thought open source was a good idea, right? You guys thought open source was a good idea, but all of your contacts are traceable. I'm gonna find you. I'm gonna tell you everything what I think about you. Who the fuck thought it's a good idea to fucking pop up a dialogue in the middle of me editing my source code? Who the fuck thought it's a good idea? Holy fucking shit. Ah! Disgusting. Absolutely disgusting. Can I do something like this? HTTPS. Maybe I can do something like prefix. Alright, so this is gonna be prefix. Prefix. Didn't I say yes? I thought I said yes. I just need to gather my thoughts. Like I'm literally in a shock. Just a second. Like I'm in a shock of how much you can fuck up the UX of your application. It's just like, holy shit. I think I'm gonna simply just restart Emacs and start over, right? So, and I'm not gonna try to do the tags. By the way, next time, Zhang, instead of like asking these kind of people, just straight up time them out. Just straight up. There's no need to warn them or anything like that. I know these people. Time them out. Don't even talk to them. Seriously, it's a waste of time. Let me see. So this is gonna be time. What was that? This is okay. Perfect size. People like this are the reason why I have to take really long breaks from time to time from the Twitch. They just don't understand. They simply don't understand. And it's really, really sad. Alright, so this is gonna be this, and there we go. strcmp, and let me see what we can do in here. Printf. You know what? We can probably do something like this. And I'm gonna use GCC this time. String.h. All right. Yep, it worked. And for instance, if I say something like FTP, right, it's not correct, all right? So, but it's literally equal to HTTPS. All right, that's actually pretty good. We can use that. We can use that, and let's see. Okay. So where is that place? Okay. If const char HTTP prefix, is it really HTTP? Was it HTTP? I think it was HTTPS, right? So we're gonna do HTTPS. We're gonna include files over HTTPS because we want to be safe. We don't want to include files over unsafe source, right? And by the way, since you can include files over HTTPS, we can now claim that C is as safe as Rust. You see what I'm talking about? Right, because we're including files over HTTPS. Does your Rust can includes files over HTTPS? I don't think so. But TCC does, actually. Alright, so this is going to be HTTPS prefix. HTTPS like this, and we also want to do something like size t, HTTPS prefix size, and then we just use strlen. Strlen. So strncmp, and we're literally going to do just. So according to what I see in here, the buffer actually starts with either this thing or this thing. So that means the actual comparison has to start somewhere at buffer +1, right? And then we have HTTPS prefix. And how much we want to compare here? And we want to compare HTTPS prefix size. Wait a fucking second. Did I remove my previous example? Fuck, I removed my previous example. I forgot. What if the original one is shorter? Fuck. That is actually really bad. Okay, so let me see what I can do in here. So I need to recover. I should have not actually removed that example. I have a really weird habit of checking something and then removing it, and then I need it again, and it's just like, bruh, no, how can why do I have this stupid habit? Like, I need to get rid of it somehow. Like, why do I remove things? I need them. If I can need them, I need to check that shit. Alright, so... Yeah, recycle bin, yeah. Haha. So where is that shit? Okay, so this is gonna be S. Alright, so... because strncmp is not really obvious how it works. It's just like, eh. So if I could use like my string view library, it would be like way easier, but it's just, I have to use C library. It is what it is. And it isn't what it isn't. Right, const size t, prefix size, strlen, prefix, and so let's do something like printf. Might as well actually do something like this. strncmp, prefix s, prefix size, right, prefix size, and another one. Instead of S, we're gonna use HTT, right? So what's gonna be the result of this kind of stuff? Okay, so it's not equal to 0, which is nice, right? It's not equal to 0. But if I say it's 3, it is gonna be equal to 0. Just the fact that I need more. Right. Okay, that explains it. So it's actually a pretty good thing to, pretty good function to check for the prefixes. So HTTPS prefix buff +1. So have we any way to... Yeah, I can actually do something like this. Trying to include HTTPS. Okay. Including HTTPS links is not implemented yet. POG. I'm gonna put POG in here. All right. So let me see. So we need to do something like make. For beast mixed, huh? I mean, we can always do something like that, but I'm not really big fan of just doing it like this. We can hard code some of this stuff. It's like 8 characters. Yeah, sure. Make install. All right. So, so this is gonna be dist bin tcc sample main. All right, including HTTPS links is not implemented yet. POG. And why did it fail in here? Oh, this is because of the location. So why are you gonna specify the location though? It's rather interesting actually. Did I remove tag? Yeah. So it's kind of annoying. The e tag thingy actually is extremely annoying when e tag updates and something like that. But at the same time, it's rather difficult to navigate throughout the source code without it, if you know what I'm talking about. So I suppose I still want to have it somewhere, right? So we're gonna have a name, H and S, or like this, right? So, and this is gonna be something like that. It's gonna be e tags. There we go. Okay, so, and tags. Oh, that's actually pretty cool. So it has a format, but how can I specify the location for this thing? That's actually really interesting. TCC error. I guess maybe it takes some stuff from the... I don't know why I'm doing it like that. Oh shit, I see. Okay. Okay, so, and in a sample, if I enable this thing, okay, so now it's working. So you're trying to include the HTTPS, but it... Wait a freaking second. Oh my god. so this is 8 characters. Then alright, so there's probably some logic, weird logic going on. I think I'm gonna make a small break. Make a cup of tea, and then after the cup of tea, we're gonna try to understand where exactly I made a mistake in here. Alright, so let's try to understand what's going on. Can I just do something like this? Yeah, yet again, I can try to print this thing like that, right? And just see what's going on here. Well, my internet is down, by the way. Luckily, I'm recording right now, so it doesn't really matter. So, this is gonna be something like this, and I'm gonna just provide the buffer, and we'll see what's going on in here. Okay. So, let's do make install. We need to understand what is going on. Yep, it is working. It is actually working, but I still don't quite understand why it wouldn't work at all. Why it wouldn't trigger an error like this. Might as well actually put something like D in here and just literally show the results. Show the results. What a horrible music. So maybe it makes sense to actually do something like make install. -1, so it didn't work at all. It didn't work at all. Oh, okay, so we don't need this thing because it automatically moves everything. Okay, so I thought, yeah, I didn't know that this entire thing actually moved it. Okay, that's pretty cool. So that explains the situation. It didn't explain anything. The fuck? Oh, a minute. Finally, yes! Yes, 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 look at that, yes! Fuck yeah. Fuck yeah. We finally actually report an error on this kind of shit. So that's pretty cool. It's a little bit messy, it's a little bit difficult to read, but I think it's fine. More or less fine. So what we can do now, we can try to maybe make a HTTP request, right? So essentially, when the buffer starts with HTTPS, we just make an HTTPS request. So let's see how we can even do that. Though I just realized that I'm not really maintaining the description file that well. So I suppose one of the things I want to do, I just want to, you know, go to different places. Like this is TinyC. Is this official TinyC? It's an official mirror. I mean, come on. Okay. TinyCC git repo. So here is that, in case you're interested. Do we need anything else right now? Probably not. Yeah, the thing that we're going to be using libcurl, right? We're going to be using libcurl for this entire thing. HTTPS get example in C. So we're just going to go through the oh, I mean, thank you, Google. Very cool. HTTPS. Yeah, simple HTTPS get. Oh, you can just... Oh. That's pretty cool. You can just give it URL. I thought you're gonna have to actually parse the URL first and shit like that. You don't have to do that. That's pretty convenient. So let's see what we can do in here. So TCCP and so this is a sample. So maybe I'm gonna do something like strncmp. Right, I'm gonna put in here. stb. Yeah, let's keep it as a sample. libcurl test main.c, and what we need to include in here. So I also want to actually put this stuff in the description. libcurl HTTPS example, right? So that's essentially what we're using here. So we need to include. God, it fucking annoys the shit out of me. I'm gonna wait until it pops up yet again, and I'm gonna try to Google how to fix. Yes. Okay. Emacs tags have changed pop-up dialog. Holy fucking shit. This is so bad. It doesn't even show. I'm gonna find the person who actually implemented that. I'm gonna find the person. I'm gonna tell them everything. Tags have changed. It's annoying as hell. Okay, and there's literally, I don't see any other way to just restart the whole freaking Emacs. That's how bad it is. My god. It just annoys me to no extent. Seriously. Like, you're really fucked up as a US developer if this is your decision. You straight up fucked up. Really badly. Okay. Freaking. Where's. Yeah. I want to do something like this. Why can't I. So annoying. Alright. So we're gonna have a curl global default. What's up with the boomer error variable declaration? Just declare the variable where you're about to use it. Come on. Okay. So if curl is this thing, if it is not, we can do something like, I don't know, report an error. Suppose say printf std error could not initialize curl context. And I suppose we're gonna just exit in with one. There we go. So easy initializer curl, easy set opt curl opt URL, and the URL that we're working with is that one. Essentially, might as well actually save it somewhere here. Const char URL. Alright, so this is going to be that. So we set the URL. If you want to, I didn't want to click anything. Holy shit, okay. Skip verification, yeah. We're not gonna skip anything, I suppose. We're gonna leave it as it is because I don't really want to do anything super fancy. So here's the, and of course res is yet another, yeah, boomer variable. Boomer variable declaration, that's what it is. Okay. You have to declare all of your variables at the beginning of the function so you know how much memory you're using and what kind of variables you need. Like, I literally unironically heard argument like that. It's freaking horrible. It's just like, IRL. As an argument why, you know, Pascal is good. And it's just like, holy fucking shit, dude. Anyway. So if it's not okay, so curl easy perform failed. All right. Std error. Curl easy perform failed. Now that's a proper Stockholm syndrome, if I ever seen one. All right. Is str error res and. I suppose we need to do an easy cleanup, right? Easy cleanup. Okay, so curl global clean up. There we go. Right. So I suppose we need to do something like package config c flags libcurl. Right, do we have a libcurl in there? I don't remember. So I can just try to run something like package config list all. Right, do we have anything in there? Libcurl. Right, so here it is. It's literally called libcurl. Nice. Libcurl and package config libs libcurl. Right, so hopefully that will actually link everything appropriately. So we need to include some other stuff. stdlib. Okay, so set opt. I think it shouldn't be perform, right? Alright. Why does every function tell you that it's easy? Because the original implementation, they fucked up so badly they had to make a separate API that is easy. Speaking of fucking up your UX, hello Gilolo, how are you doing? Alright. Could not initialize curl context. Did I make a logical mistake? I suppose yes. It has to be equal to null. Alright, so here is the header. There we go. So we managed to query a header over the over HTTPS. So that's the thing we want to do in here. Where are we going to be saving all of that stuff? I don't know. Okay, so as far as I know, there's a couple of things that you have to do in curl. Specifically, you have to globally initialize it and then clean up after the end. I don't think we need to clean up anything. I suppose cleaning up is important because curl has this sophisticated context with pool of threads that maintain several connections for keep alive and HTTP2. You know what I'm talking about? Because of the modern web protocols are so fucked up, you needed like a complicated system just to query its text over the network. Right. Because of that, you have a special cleanup function that properly closes the connections of these thread pools and connection pools and all of this weird shit just to query text over the internet. That's why it's kind of like bad to skip this global cleanup, but at the same time, do we really care? We're not going to be doing anything super sophisticated unless, it depends. It kind of depends. Maybe for now it doesn't matter, but in the future it's gonna be actually very important. So anyway, what I wanted to do, I wanted to see where the entire execution actually starts, right? So we can put this curl global initialization at the beginning. And yeah. Tiny cc, right. pp talk include, right. So what's the function? Oh, it's the function that is responsible for preprocessing is literally called preprocess. Isn't that beautiful? I love shit like that, yeah. Here's the C compiler. Any C compiler has a preprocess step. Guess how the function that performs the preprocess step is called? It's called preprocess. Yeah, I absolutely love it. Like, we need more software like that. Like, holy fucking shit. What is both? It's true if first non-space token is begin. Whatever. Nobody gives a shit. But yeah. So yeah, who would have thought, right? Apparently, you don't need factories and abstract bin generators and, you know, dependency injectors just to preprocess a goddamn file. Apparently, you just can have a function that performs the preprocessing. What kind of magical technology it is? I don't know. So, what I wanted to do is I want to see if the TCC has debug information. Let's go to the dist bin and let me take a look at the file. With debug info, would you look at that? Isn't that amazing? It has a debug info. Amazing. So I think I actually want to start tmucus. Sodding TC curl. TCC is POG as fuck. It is. It is in fact POG. Isn't that POG, fellow kids? Oh. So sorry. All right. So, and if I run something, I suppose I want to just run it with sample main C, LM, but I also want to break on preprocess. Yeah, so I'm breaking on preprocess, I'm running this entire thing. Right, and in here, what I want to do, I want to simply take a look at the stack. All right, that's a big stack. Would you look at that? It's just like main, tcc.c332, okay. Let's find tcc.c, tcc.c, 332. There. What? The main itself is like, yeah, there we go. Here's the entry point to the compiler. I'm entering the compiler. So that's basically what I want to put in here, just to confirm that, yeah, we're entering the compiler. Alright, so make install. Well, yeah. I guess make install. Hands up! Okay, and then if I do something like dist bin tcc, there we go. And I fucked up the new lines, but apart from that, seems good. Seems good enough. Yep. Yeah, there we go. I'm entering the compiler. That's what I'm doing. Entering the compiler. So, and this is precisely where this is precisely where we want to actually initialize the curl, right? So, so there's a tcc.h. Maybe this is the place where. Oh, okay, so this is where we include all of this shite. So let's actually include curl in here. Curl in here, and let me see if I can compile this shite. I probably won't be able to compile this shit. It will tell me, bruh, I don't know how to find the curl. So far, doesn't tell me anything. It's actually rebuilding everything. I'm surprised. What the fuck? tcc.c. So what if I do something like this? Oh, okay. So it can already find it apparently. All right. Okay, cool. So, and that means in TCC, I want to do the following thing. So this is going to be main, and we're going to simply initialize the global thingy. So, curl global init. Curl global init. Curl, and there we go. Does curl global init actually return anything? It returns curl code, right? So if the function returns non-zero, something went wrong, and you cannot use the other curl functions. Okay, so it would be kind of weird, right? If your compile failed because it couldn't initialize the curl context, but this is precisely what's going to happen. So I suppose here we cannot use the regular error thingy. So, oh, actually we can, apparently. Alright. So maybe I can do something like tcc error. Could not initialize global curl context. Yes, your C compiler is using curl. Okay. So do I have to, does this thing automatically exit? Yeah, it is automatically exiting. Okay, so I don't have to worry about that. Perfect. Also, I think we'll probably need to set up the context first. Yeah, because the error probably uses the TCC state. Yeah. So, and here's where we're initializing the state and stuff like this. So I think we need to actually put it somewhere here, otherwise we won't be able to do that. There's also redo. No. We want to actually initialize this entire thing once. That's for sure. We don't want to initialize several times, so that's why we're not going to do redo. Do redo. Alright, so let's try to recompile this entire thing. So undefined reference, okay, this is precisely what I wanted to see. I wanted to see if it will fail with this kind of shit. Okay, we need to extend the build system, and we need to make the build system link everything appropriately. So do I have to go to the config or something, maybe? So do you have LM? Oh, this is where we have LM. So if we are on Windows, right, we're doing that. I guess we can do something like this, right? So libs, the fuck, yeah, let's put libcurl in here. Okay, so we're gonna just try to link this entire thing with libcurl. Okay, so it worked. So yeah, your compiler now complains if it cannot initialize the curl. Oh, by the way, this is rather interesting. If I go into the dist and take a look at what the compiler depends on, holy fucking shit! This is all of the shit your compiler depends on now. All of that came from curl, right? GHTTP2. RTMP, SSH, SSL, crypto, KRP. In a comparison, I think we can compare this kind of shit. Wait a second, I want to compare that. The fuck, this is so funny. So if I remove that and TCCC and just remove this shit, right? So let's try to recompile this. the stuff, and then you do LDD dist bin TCC. In a comparison, this is how dependency look like without curl. If your compiler doesn't depend on curl, it literally depends only on mathematical library and libc. Which is another interesting question. Why the fuck compiler depends on mathematical library? And I know for a fact that, well, I mean, no. Why? Do you need something like floor or ceil or maybe sine or cosine for compilation? It's like, I'm not quite sure. Is it like, does anyone know why a compiler, const folding? That's a good point actually. Okay, yeah, you guys are right. It's probably const folding. That's a good point. But yeah, alright. But anyway, so we're not here to be reasonable, right? So we're here to have fun. That's why we're gonna depend on all this shit, so... right, because our compiler needs to be able to make HTTP queries. Your compiler must be able to do that. It's 2021, goddammit. It's 2021. Time to make HTTP queries from the compiler. Let's take a look. Hogweed? What the fuck is Hogweed? I really like that. Nice. Anyways, we initialized everything. Is there any place where we can put cleanup or something like that? Run tests. It doesn't seem to be using like a cleanup function at exit. Does it have at exit? Maybe not. So even TCC error, right? If you take a look at TCC error, it simply does exit. Illuminate this someday. What can you replace it with? Better than nothing in some cases we accept to handle errors. Oh yeah, I see. So basically they need to be able to catch the error, and yeah, that's why they have a long jump or something. Alright. So TCC error. I want to see how the failure is going to look like. Yeah, no. Let's first see how the success looks like. Because I actually never run this entire thing properly. Okay, so it doesn't seem to be that bad. And now, if I go to main, where's tcc.c, let's quickly swap it up. It's just segfaulted. That's a good point. So this is precisely what I was expecting, because I think TCC error simply doesn't work if the context is not initialized. But the context initialized in a place where you can try to initialize the global variable twice. Can I actually call this function twice? Oh, multiple calls have the same... Okay, that's perfect. This is actually perfect. So I can actually call this thing multiple times and it has the same effect as like one call. Alright, so maybe because of that I want to actually put it in here, right? So because I feel like TCC error is not callable unless you initialized everything, right? You know what I'm talking about? Yeah, I was right. I was right. So you cannot call TCC error unless you prepare this kind of stuff. Unless you created like a new context and parse the arguments and shit like that. So yeah, and since the compiler can actually do redo, I was actually worried that maybe calling curl global several times would be bad, but apparently it's not bad, so it's totally fine. Alright, it's totally fine. Alright. This is CPP talk include. So HTTPS. Okay, there we go. It's actually super easy to find this code. You just search for HTTPS and it just works. So in here, I suppose we want to do curl. We want to create the curl context. So lib curl. Yeah, we just need to do this kind of thing. Yep. If curl. We have to do could not initialize curl context. So that one was global curl context, right? This is a global curl context, but this one is like a single local thingy. All right, so after that, what's the next thing? We need to set the URL for this entire stuff. So curl URL, and the URL is equal precisely to buff, right? So we already established that this is URL, and I suppose then we just perform the query. We just perform the query, but we need to actually save this entire thing to a separate file. So the thing is, curl by default prints to std out. So that's why it's not going to work that easily. So maybe we want to do something, we want to do a little bit more experimentation, if you know what I'm talking about. Experimentation of our nation. I'm sorry. If I remember correctly, when you set OPT, you can actually set different things and whatnot. Where is the example? So set OPT. Curl header. Yeah, curl write function. Right, you can set your own curl write function. So in here, does it have a default one? I think default one is literally f write. Yeah. It's by default it uses f write. So the thing we have to set in here, I think we need to set write data. All right. So, and in that case, write data has to be the file. All right, so let's do the following thing. Let's open file, open, and we're going to open it for writing, right? We're going to open it for writing, and the name of the file is going to be whatever, stbimage.h, right? So, and of course, at the end of this entire stuff, we need to close that file. So, we need to probably prepare this thing here. So here's URL, then curl easy set opt curl curl write data, and write data is going to be literally that file, so that will make the curl actually write the content into the file, right? So we have a make file in here. Okay, so boom, as you can see we have nothing in the folder, but if I run this thing, it's segfaulted and nice. Cool. Maybe we need to assert that this thing is not 0 or something like that. File not equal to null. Right, so let me see. All right, okay. Let's also include assert h in here. Okay, so it is in fact equal to. Oh my god, I'm an idiot. Okay. It's the other way around. Okay, and it created stbimage.h. You see? Here it is. Here it freaking is. Isn't that amazing? Okay, go. So now we need to repeat that in the compiler itself. So tccpp, right? tccpp. So we set the URL. We set the URL properly. I suppose here we also need to open the file, so let's literally call it just a file, fopen, and it's gonna be just a random name, whatever, right? So const char file name, it's just like literally whatever, just create some garbage in here, and we're gonna open it for writing, and if file is equal to null, that means we couldn't open this file, right? Something like tcc error, could not open file this thing because of this thing, right? And file name is that, and the error is going to be error null like this. There we go. So after that, we're setting the URL, and we need to set the write data, I suppose. Write data, and this is going to be like the file. So then we perform the query, and if the result is not okeg, curl e okeg, we're also going to throw an error. TCC error could not download this thing because of that thing, right? So, and what's the next thing? I think it's that, it's the buffer, and we use curl easy str error resource, right? So we just, you know, we just failed the entire thing. Right, after that, I want to do curl easy cleanup. I'm going to be cleaning up the entire thing, and I suppose I also need to close the file, right? So after that, I can replace the actual buffer with this thing, right? Because I know for a fact that the content that I want to include is located in there. So as far as I know, we have to do tcc open, tcc open. So as far as I know, if it failed to open, we have to report some sort of an error, right? So what is S1? Excuse me. Oh shit, it's some sort of a state. Where can I get S1 though? Is that something that I have? I think this is something that I literally have, so I can just directly use it. So tcc open, there we go. So let's go back, HTTPS, and I said HTTPS, there we go. So this is going to be file name, go. And if this thing failed, we can print something like tcc error could not include downloaded file. And this is the file that we just downloaded, right? So there we go. That should be it, believe it or not. That should be literally it. So here we encounter something that starts with HTTPS. We initialize in the curl, open the file with just random name. So the name could be, for instance, hash of the buffer. It could be hash of the buffer. We can implement that as well. Right, we set the URL, then we set the file as the, you know, sink for the data. We perform the query, then we clean up curl and close the file, and then we tell TCC open that file instead. By the way, after that, I think we need to do go to end, because every time you successfully open the file, right? You successfully open the file, you need to go to the end. So including, so you also add, oh, this one is weird actually. Right, I feel like you need to do this kind of stuff. Yeah, I think we literally need to copy paste this entire thing in here. Right, because after you open the file, you just do this preparation, and so on and so forth. There's also dynamic array, include stack, otherwise it just like won't work properly. Buffer, PTR. I'm actually kind of scared to do that. Well, let's go and do that. Let's just copy paste this entire thing. Oh shit. Well, I could try to reformat everything, but I don't think it's gonna be a very good idea. So I hope I didn't fuck up stuff too much. Oh, okay, so that's totally fine. I already called a formatter on the whole file accidentally, so that's totally fine. So everything is rude anyway. That's totally fine. Luckily, we have a version control system, so it's not that big of a deal. Okay, so okay, so let's try to compile this entire thing. Make and make install. So it's gonna be tiny cc. Is it compiling? It is not compiling. All right, so this is fine, whatever. File is already taken. Okay, so I need to rename the this thing to something like download file. So because of that, download file. So should be fine. Another one. Okay, so what we put in here, update target dependencies. Okay, so we adding buff1, but buff1 is literally the one that is appended. That one that is appended. So that means in our case, we need to add file name in here, right? Right, because what we do in this loop, if I understand correctly, we iterate through all of the include paths, concatenating them with the target, right? And buff1 contains the target one, right? And it contains the target one. Since we're adding the one that we're including, I suppose we just need to put a file name in here then. All right, so is it working? Is it compiling? Okay, so implicit declaration of curl easy cleanup. Okay, so this is very easy to fix. I think I need to go in here. I already included curl.h. Why it is not included properly? Curl.h. Maybe I need to include it like I don't know, somewhere here. Implicit declaration. I'm actually so confuzzled. Like tcc.h, right? Here it is. I go into the tcc.h. The first thing that we include in here is curl, and it's just like, no, it doesn't work. Is that because I fuck up the name of the function? It feels like maybe I fucked up the name of the function. Curl easy clean. Oh, it's clean. Yeah, you're right. Thank you so much. All right. Okay, so initialized value I+1. This one is rather interesting, and all right, include the next index. What is up with I+1? So I is used in here. Include next index. I'm not sure what the fuck is include next index and why the hell it is there. But it is in fact there. Include next index. I hope it's not some sort of a weird hack. Hope it's not some sort of a weird hack. So maybe I need to actually take a look. Next search path. So I is an index in the amount of you know what? I have a strange feeling that maybe I should try to pass. Yeah, I think I shouldn't try to do this kind of stuff myself. What I need to do, I need to replace buffer and just let this entire thing continue. You know what I'm talking about? Yeah. So what is just buff? True file name. how the buff is actually used. So then P ctr buff. I see. And then we do the final thing. What I need to do in here, by the way, I need to replace whatever inside of the buff with the new file name. That's what I need to do in here. But I'm not sure what is buff itself. Is it some sort of array? Can I just like quickly... I cannot actually jump there. So it probably defines somewhere at the top. Oh, it's just a buff. Okay. This is actually pretty cool. It's just a buffer, and how is it used? Right. So, alright. Q buffer. Alright, so include next. We initialize like everything. Alright, so my idea is the following. Fuck all of that, and especially fuck all of that. Right, so we're done with this thing. We are including yeah, what I need to do, I need to copy this entire thing into the buffer. So strcpy. Can I do that? So copies the string pointed by src included in the terminal to the buffer pointed by dst may not overlap, and the destination string must be large enough to receive the copy. Beware of the buffer overruns, see box. Well, yeah, and that's why you probably need something like n or whatnot. Similar, except that most n bytes of src copy, where if there is no ultimate among the first n bytes of src, the string placed in will not be ultimated. What's the point of this thing then? Okay, maybe for now it doesn't really matter that much. What we can do just str and cpy, right? Str and cpy. The destination is going to be buffer, the source is going to be file n, and we're going to have a size of at most. If the length of src is less than n, writes additional bytes to ensure that the total n bytes are written. All right. So, and let me see the stuff. Buffer file name, and it's just gonna be like this kind of thing. All right. So that should be it. We download the entire thing, and we just copy it into the buffer, and we're just letting the rest of the code responsible for searching for include paths to do its thing. Right, so that's precisely what we're doing in here, right? And hopefully that will work. I'm not sure. We'll see. The winner gets T, that's for sure. And we have some problem with this thing, and I'm not sure what the fuck is this. And declare first use this function. Did you mean talk default? Maybe, but actually not. I don't remember making any changes in here. Is that because of the curl? TCC is native, TCC is PE. I don't know. what did I do? I don't remember. We can try to stash the entire thing and just try to run it one more time. Will it be failing like this? Maybe. It's something with DL, and I do roughly remember. Is it because this thing should accept a single stuff? Curl LDL or... Huh. Not quite sure, but yeah, it is working. It is working more or less. Okay, so if I revert, right, and if I just add the curl, will it work? Guess I fucked up something accidentally. We'll need to find out. We'll need to find out what precisely I fucked up. Luckily, we have a version control system. That means if I fucked up something, it's not that big of a deal. It's not that big of a deal. So here is the changes that we made. So in here, HTTPS. So the most important change in here is like this chunk of code. So it's actually quite cool that the entire implementation of this feature is like literally a single chunk of code that you just add and don't touch anything else. And if it's gonna be possible to actually pull that off, I'm gonna be super happy. All right, so what I'm gonna do here is I'm gonna revert all of these changes. Right, I'm reverting all of these changes, and I'm simply trying to compile this one more time. One more time. Okay, is it compiling? Is it compiling? All right, it is not compiling, even though I didn't make that many changes. I have a feeling that it could be because of this kind of stuff. Yeah, okay. So maybe we can include the curl somewhere in here. So if one source libcc include tools, and let's also include curl curl.h in here. It feels like maybe curl fucks something up. It could be curl actually fucking something up. Yep, called it. So this was because of libcurl being included in tcc.h. So I suppose libcurl included some macros that fucked up the macro system of TCC. Something weird has happened there. I don't know precisely what, but something definitely happened there. All right, so let's go back to TCCPP. And here we're gonna try to include our chunk of code. So it's somewhere doc include. So let's see. So this is where we checked for everything. And now I'm gonna go to the TMP. And that's precisely the piece of code we need to include in here, right? So we check if it's like starts with HTTPS. And see. So let's see if it's gonna compile or not. All right, so unknown curl. Okay, so that's fine. That means I need to probably include this entire stuff in here. So it's gonna be something like curl curl.h, right? Curl.h. Let's try to compile this entire stuff. This motherflipper compiled, believe it or not. This motherflipper compiled. Holy fucking shit. Okay. Okay. Very interesting. So I kind of want to make a slightly different change in here. HTTPS, where's my TCCPP? HTTPS. I actually want to give it a more or less proper name. TCC curl download. Right, so this is the thing I want to put in here. TCC curl download. Holy fucking shit. Whatever. And let's rebuild it, because I want this file to be visible in the current folder, right? And all right. I'm still a little bit anxious. I'm really sorry. I just need to do the following thing. So inc debug. Okay. So now look. Let's go to the sample, and here in a sample we have this kind of stuff, right? So I'm gonna straight up remove everything, right? I'm removing all of that shit. It doesn't really matter, right? So here's the source code. We're including STB image and so on and so forth. If I try to compile this entire stuff with GCC, right? the GCC will fail saying that no such file or directory. It was trying to include this shit, but it couldn't include this shit. Alright, so the same file, can we try to compile the same file but with hacked TCC? So this is the moment of truth, by the way. TCCO, this is going to be main, and we're going back to the sample, main.c, and we're also going to be linking it with the math library. There we go. It tried, and it actually failed with TCC curl download not found. Huh. Alright. TCC curl. Here's the file, but it couldn't find it. That is very interesting, actually. Is this because it didn't search in the current folder? It could be because of that. So if we try to do some... Okay, I'm gonna try to remove this download. I'm removing this download, and I'm gonna try to run it one more time. Okay, so if I try to do that, it works. And if I try to run this thing, sample sodding flushed, it downloaded the header from the internet. Holy shit! It fucking works. Yes, you can include headers over the internet. Holy fucking shit. The problem is that it's like not particularly convenient for some reason. I cannot compile it inside of this sample. I didn't expect to actually pull that off. Because before the stream, I just briefly looked into the source code of TCC, and I was just like, it's probably doable, but I didn't go into details, and I was actually really skeptical. I thought maybe I'm gonna spend like a huge amount of time debugging all that, but it was actually pretty straightforward. Right? You just glue together TCC and curl, and you can finally query them. So, alright. Let me see, I want to fix one problem in here. So if I try to do sample, not sample but tiny cc, include, not include but rather dist, bin tcc o main.clm. Yeah, it doesn't work because it's trying to search the includes in a really weird place. Probably because the prefix installation for TCC is relative. I think I need to make it some sort of like absolute. Right, so one of the things we can do in here, I have an OPT folder in a home folder, right? So I can probably do something in there. So we have Guinea. Okay, so I can just do TCC. All right, so let me go in here, and I'm gonna quickly remove dist. Right, so dist does not exist anymore, and we're gonna reconfigure this entire thing with a prefix to be equal to home. Actually, just a home opt tcc. So this is going to be the prefix. Right, so now the prefix is absolute path, which should be a little bit more convenient, and let's actually try to install that, compile and install that. Alrighty. Alrighty. Sample, right, and if I try to run my opt tcc bin tcc o main.clm, it is working, so it's actually searching for the headers in the correct place. Okay, so can we actually include several headers in here? That's a good question. So one of the things we can do in here, for instance, is make this thing transform the image. You know what I'm talking about? So basically it will take one image and make it grayscaled, for instance. Right, and because of that we'll need a second library. This library can only read images, but it cannot write them. So let's include the second library that can write the images. So nothing's stb. And I think it's literally stb image. Ralph, thank you so much for 16 months of tier 1 subscription. Thank you. Welcome. All right, so I'm gonna grab this entire thing and we're gonna include it right here. There we go. It would be even cooler to sort of like grab the name of this thing somehow. And as far as I know, curl is capable of parsing URLs. Shit. Alright. Alright. So we should be able to actually extract this kind of stuff. So it can parse the URL. So yeah, and it would actually, it would actually download it locally. And for instance, it may check if it exists locally, it will not download it. That's so cool. I actually like that. Okay. You can actually extend this system. You can cache the files and shit. And it's right there. All right. So what I want you to do, I want you to see how it will play with 2 files. So stbi write, and what we're trying to do in here, we're trying to write a PNG. So this is going to be, I don't know, I think we need to accept the output as well. All right. Okay, so this one is going to be something like const char output file path argv2, and because of that also this thing has to be like 3, right? So this is the pixels that we've got. So, and I don't really care about the components, but I want the components to be like 4 of them, right? And because of that, this is going to be uint32t, and there we go, we have pixels in here. All right, so how are we going to be approaching this entire stuff? So I need to iterate rows and columns. So x is going to be that, h, w, h, there we go. Y 0, y less than h plus plus y, right? For int x, w plus plus x. Okay, to be fair, maybe it's not really needed because I don't care about the dimensions. The only thing I need to do in here is traverse each individual pixel. So because of that, I can just do something like I, from 0 I, w multiplied by h, and it's going to be like I. There we go. And pixels, I, grayscale that pixel, and we're going to be reassigning that pixel back when it's grayscaled. So the only thing we'll need to implement, this function. All right, after that, we're going to be taking output file path, width and height, amount of components is 4, data is basically the pixel, and stride is in bytes. If I understand correctly, is basically width, but in bytes. The size of a single pixel is 4 bytes. It's the amount of components, essentially. So it's basically going to be width multiplied by n. Yeah, it's going to be multiplied by n, and because of that, it has to be like n or something like that. Though I'm not sure if it's... I think I'm going to actually do something like comp. It's going to be 4. It's the amount of components that I want to have. Right, so this is going to be comp, and this one is multiplied by comp. Alright, and if this entire thing has failed, we're going to be just printing an error. fprintf std error could not save file this, and this is going to be output file path, and we're going to exit with 1. Right, so we'll need to implement this simple function that accepts 32-bit number, right? So this is going to be in 32 pixel, right? So how can you implement such pixel, right? Well, the pixel probably will look like something like this, right? So I suppose it's RGBA or something, and the alpha in that particular case is going to be here. So these components are going to be R, G, and B, and it doesn't really matter which one is which, because this is a grayscale. So we need to find the maximum between them and just reassign them all back to all of them, if that makes any sense. Not sure if that makes any sense. But yeah, so the first one is going to be essentially, so pixel is like roughly equal to that. This is probably alpha. This is probably R, G, B, and then alpha. But it doesn't really matter. Doesn't really matter. So I'm going to do something like this. So this is going to be A, this is going to be B, but pixel is going to be shifted by a single byte. Right, so and C is the same, but shifted by 2 bytes. This one, you can think of it as shifted by 0 bytes, right? And this one is shifted by a single byte. There we go, so we have A, B, C. So we need to find the, minimum or maximum between them. Or maybe even average between them. I don't know. It just depends on what we want in here. uint 32t, right? So uint 32tx. I'm just thinking what's going to be the better way of doing that. So this is going to be 8. Uint 8tx a if x is less than b, x is equal to b. If x is less than c, x is equal to c. So in C there's no min and max functions, so we have to sort of deal with this something like this. We can even do something like this, like if x less than a, x is equal to a. Yep, pretty much. All of that's going to be sort of const, not cost, but const. Right, and I suppose now we can do something like a f and x 8 2 0 1. So we basically disassemble the components of the pixels, and then we find in the maximum between them, and then we assemble them back. Right, so that way we can achieve sort of grayscale-ish look, more or less, hopefully. I have no idea if we will. Maybe we also need to include things like stdint, but I'm not sure if TCC even supports stdint or anything like that. We'll see, we'll see. But yeah, so let's try to recompile this entire thing, and okay, assignment from incompatible pointer type. Well, thank you so much for telling me. That's actually pretty cool. Apart from that, it managed to do that, and also there's x. Oh, this is 1h. All right. Pixels undeclared. Anything else? You have to. It compiles. This motherfucker has 2 of these things, and it compiles. It just freaking compiled. I can't believe that. I refuse to believe that. It was like basically rewriting to the same file, but yeah, apart from that, it's actually working. So this thing accepts input and output, and the input. This is how the input looks like. So it's a Tsoding flashed. You can use this emote in the chat if you want to. So it's a Tsoding flashed. It's me every time somebody subscribes. So yeah. Alright, so we're gonna do Tsoding flashed, gray PNG, and it created Tsoding gray, and it actually made it grayscale. Holy shit, it worked. It fucking worked. Yes. This is so cool. Yeah, you can include files over HTTP. You know what's cool? You can include files over FTP as well. Because curl supports shit ton of protocols. Curl supported protocols. And as far as I know, they all have the same interface. So you can include files over these protocols. We just need to add a corresponding checks in TCC. In TCC, we only trigger curl on HTTPS, but theoretically, if you check for these extensions, you can include files from anywhere. So yeah. Holy shit, it just works. I can't believe that. This is so cool. All right. So that is amazing. That is absolutely amazing. Okay, so maybe I want to like see how we can parse URL, because the coolest sort of touch to this feature would be if it actually used the proper names. Right, so if it actually like download and put this file into the file system, that would be absolutely beautiful. Get a header file. Yeah, imagine getting a header file from email. My God, that's so cool. To be fair, huge props to TCC developers. Seriously, this is not my achievement. This is literally an achievement of TCC developers. If they didn't make their source code, their code base so simple and so approachable, I wouldn't be able to do that. I just won't be able to do that. So majority of this stuff is actually because of the TCC developers. Thank you so much, TCC developers. Unironically. All right, and of course, thank you, the curl developers, because I mean, curl is a huge part of this feature, right? Without the curl, you won't be. I mean, without the curl, technically, you could open a socket and just download it yourself, and it would work for like a very narrow cases and stuff like that. But curl just makes it cooler because it can work over so many protocols. You know what I'm talking about? Yeah, can you imagine do that in GCC? When I was preparing for the stream, the first thing I looked into is GCC. I just downloaded the source code. I just looked into the stuff and I was like, nope, that's not how it's gonna go. Nope, 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 I'm not doing that. Fuck that, fuck that. Okay. So, let me see. Doing SSL handshake with sockets. Well, you can use OpenSSL. And if you want a simple example on how to use OpenSSL, there's this gist, which makes a simple HTTPS GET query without curl. Yes. So here on Linux, we're opening a socket, we're doing handshakes and stuff, and we're just literally making a simple HTTP GET, and it works. Okay. All right. Let's see how you can parse the URL. So is that what we have in here? Okay. So lib curl URL parsing example. URL parsing example. So that's pretty cool. So, okay, so you first have to create something called curl URL, curl U, right, it's a curl U. So then we set the URL, and then we can get different parts of the URL. We can get the host, we can get the path, and so on and so forth. And is there a list of the components that we can get? What? What? Parts, URL, scheme, user, path, query. I guess we can just try to take a look through all of them. And we can try to look through all of them. All right, so let's go. Let's go. To curl and libcurl test. All right, so this is basically HTTPS. Right, so this is HTTPS. HTTPS URL.c. So cool thing is that when you just want to parse the the URL, you don't need to set up the global context and shit. stdio include curl curl.h, right? Copy pasting code. Zozin, how do you know so many things? Zozin, in the meantime, copy pasting from the internet. All right. All right. So, and then we're just setting the URL. And this is so weird. Like, you're setting the URL and you have a return code. Oh, it returns you whether it failed or not or something. I see, I see. So this is the host. I suppose, yeah, I see what's going on. So we don't need any of the shit. We're gonna just ignore that. So no need to be pedantic or anything. So here we are extracting the host. So set the URL. Get the host. Path. Okay, did I not fuck anything up? So this is host, this is path. Alright. Replace HTTPS. There we go. Okay, so if I run... Wait, come on. Okay. Okay, so we got the path, but I want to actually like file name or something. I want more shit. So user password, options, zone ID, path, query. Probably will get pluses converted. Yeah, I suppose we have to take the path and we'll have to parse the rest of the stuff ourselves. I think I have a strange feeling that we'll have to be forced to do that ourselves, if you know what I'm talking about. And it's kind of sad. It is truly sad, but it is what it is. And it isn't what it isn't. What if it's something like this, right? So if we try to do it like that. Yeah, the path is gonna be just that, which is actually kind of cool. And it also removes all of the get stuff, so it already does a pretty huge portion of work. It already does a pretty huge portion of work. I don't think we need to do anything else in here. So, but the question is how we're gonna be parsing all of that stuff. So essentially we could have a function that could return us like a new, like a substring, because it's going to be just iterating starting from the beginning, right, until it sees something. Okay, char, const char, right, name from path, right, and here we accept the path. I have no plans for modifying the path, right. So the only thing I care about is the length, right? So this is going to be const size tn strlen. So this is the path, and while path n-1 n is greater than 0 and n-1 is not equal to that, what we're going to be doing is maybe it's going to be slightly different, right? So here is an example of what I'm trying to parse in here, right? So that's what I'm trying to parse. Oh, and an interesting thing, what if I have dash or slash in here? Will it handle it properly? Will it handle it properly? Hopefully it will handle it properly. So let me see. It is not handling it properly. But maybe it's not even needed to be handled properly, because if it had, yeah, so additional slash actually changes the semantic of the URL. I don't think it needs to be done. Base name, is base name a function? Oh, it is a function, thank you. So we could probably, yeah, all right. Okay, so would be even easier. Thank you. Random chatter in the chat. Okay, so base name, implicit declaration of a base name. Is it even cross-platform? By the way, if it's not a cross-platform, I'm taking everything back what I've said. libgen. What the hell is libgen? glibc. POSIX. Well, it's at least it's part of the POSIX. Some sort of weird extension stuff. Okay, so the interesting thing is, does tinycc even use libgen or something? Let's actually see. Libgen, whatever the fuck it is. Base name. Okay, so it does. Oh, it does have TCC base name. Would you look at that? All right. So let me see. Oh, okay. So we don't even need to use a base name because TCC has its own base name. Perfect. Because base name is not cross-platform, right? And TCC, as far as I know, it also tries to work on Windows. Right. So that's precisely what we're using here. Nice, me likey. Okay. What we'll need to do in here, it's kind of like meh that you have to like allocate memory, then set some stuff, and then don't forget to deallocate the memory. So we have to do URL cleanup, but it's curl being curl as usual. It is what it is, and it isn't what it isn't. Okay, so libtcc, and let's go to tccpp.c, and this is where we're going to be preparing all this stuff. So the first thing we'll probably need to do, we'll need to figure out the file name. That's for sure. That's for sure. Okay, so it's going to be curl u, and this is going to be URL, curl URL. There we go. So then we set curl URL set, URL, curl URL, curl u part URL. Right, and what we set in there, we set buff in there because that's what it is, and also we set 0. That should be it. But if setting failed, why could it fail? Yeah, this is so weird. I guess the only reason why it could fail is because it couldn't allocate memory or something. But you have to be like super careful with this kind of stuff, and you have to constantly check all of this. Okay, curl u code rc. Sure. All right, rc. Okay, if rc, if not rc, we have to throw an error. tcc error. Could not parse the include URL. Right, so that's what we're gonna do in here. Right. So the next thing we need to do, we need to get the file name, right? So, or at least path, right? So this is going to be something like char path, right? Char path, curl URL get URL, curl part scheme path 0, and this thing can also return RC. By the way, why do I have to have a separate variable for that if we're gonna be just... Yeah. Why can't we just do it like that? Like, sometimes like curl is just like, what are you doing, curl? could not parse the include URL. So that after that we have a path, and I suppose the next thing we do, the file name is essentially going to be tcc base name path. The question is, if your base name is something like /, what is it going to be equal to? You have to be really careful with this kind of stuff, I suppose, but it probably would be fine. Okay, so curl is init, then we do a cleanup, and oh, you also have to not forget to free this thing. Oh my god. Okay, so yeah, we're freeing the path, right? We're freeing the path, and we clean up the URL. Oh my god, curl, curl, why are you doing all of that? And then people look at these kind of libraries and they start to think that array AI is the cure for all of the complexity, when in reality it's just like shoves the complexity under the carpet without really solving it. But yeah. The memory allocation scheme in curl is just absolutely horrible. It's like, holy fuck. But I suppose it's maybe, it's a very old library. It's a very old library, what can I say? And it also needs to work in so many different environments. It's just like, Okay, so it is complaining about some of the things. ISO C90, it's not that big of a deal. As soon as it specifies the boundary. Oh, specified bound equals destination size. All right, so is that something bad or what? I can put like -1. Is that better or what? I'm not quite sure. Does it need extra? It feels like it needs extra or something, because that's precisely. Okay, whatever. Well, we're not gonna have that big of a buffer anyway, so whatever. Alright, so we managed to compile this entire thing, and it installed everything. So now, the moment of truth. I'm gonna be removing this tcc curl download. Will this thing download the appropriate files? Right, so here's the hello. I don't think we need this kind of stuff. Right, so here's the thing that we have in here, right? It should download two files in here, stb image and stb image write. Will it do that? Let's see. tcc bin tcc o main c lm, and I could not parse the URL scheme. Okay, so that means I fucked up. Could not parse the URL, the include the URL, but I'm not sure which one. tcc pp. I really don't know why. So is it could not extract path from the include URL. Let's actually have like a different names in here. Right, let's have different names. And if I go in here, so this is going to be the sample, and can I just run this thing? Could not parse. Yeah, it literally couldn't set this thing somehow. It just didn't work. Okay, it just didn't work. I wonder why though. So I created the curl. I created the curl. Did you make TCC? No, I didn't make TCC. I made a really stupid mistake somewhere and I can't see that. Okay. So I need to actually compare. This is because I'm really tired already, right? So because I've been doing this kind of shit for almost 3 hours non-stop, and I'm starting to just fall asleep. Okay, so create the curl. Curl upart URL. Buffer does contain the URL. Okay, that makes sense. If this thing is not... oh. It's considered a success. Okay, it's a completely different logic. Okay. I see. So yeah, I'm starting to make mistakes. All right. Let's try to recompile this entire thing. All right. So it was reversed logic. That's what it was. All right. And if I try to now compile this kind of stuff, okay. It downloaded both of the files though. It downloaded both of the files though, so implicit declaration of assert, well, I mean, we can include the assert, not that big of a deal. Anything else? Implicit declaration of fprintf. It kind of worked without any of this shit, you know what I'm talking about? It's kind of like, why are you asking me to include that stuff now, when it worked fine without all of that? Okay, it feels like it might be... Okay, so it might be didn't include this kind of stuff. Alright. So here's the file name. So we open the file name, couldn't open file, and we copy it back into the buffer. Right. We're copying it back into the buffer. I wonder if... what if buff actually... So just because we said it like that, it could be... I don't know, no, it probably shouldn't modify anything in here, so I don't think so. Ah, I know. Yeah. Because file name is part of the path, is a substring of path, and we're cleaning it up before copying it, so it might be actually... Okay, I see what's going on here. But I mean, of course, after that I have to reinstall and recompile everything, hopefully. So let's... Well, technically it already downloaded everything accordingly. As you can see, it downloaded both of the files accordingly. Right, so let's actually delete them and let's try to run this thing one more time. And yes, so this entire thing compiled and it downloaded both of the files. You see, chat, I do understand that everything I do is fucking boring, but look, I hacked TCC so it can now include things over HTTP like that. So you literally include this thing like this, and TCC automatically downloads it from internet and includes it in here. Works. We can try to do other things. For instance, I have a library called SV, if anyone is interested. So it's a string view library, which is actually pretty cool. We can try to include that thing. It works really, really well with STB style header-only libraries. It's just fucking amazing. Alright, so let's try to include this thing. So let me see if I add this stuff in here. So I should be able to just include this stuff like that. And let me see. So I'm gonna just boom. Ignore unknown proposed and directive inc. Oh, okay. So include. There we go. And here it is. It downloaded this file and it actually included it, and it's so fucking convenient. Oh my god. This is so awesome. Okay, I want to share this work with everyone. How can we do that, chat? How can we share? And it's not even that hard. This is the entire patch. Believe it or not, this is the entire patch. So, what I want to do, I want to kind of include like author information or something like that. If you know what I'm talking about. Hacked by Sodin.org. Available under public domain. Available to everyone under public domain. Okay, so this is going to be the entire patch. Can I quickly save this as a patch? Alright. I can probably make a commit. Make it possible to include files over HTTPS. Right, and I remember there was something like format patch. Does anyone remember how to do that? Git format patch. Prepare patches for email. Okay, git format patch head. Did it create anything? Okay. Okay, that's what I wanted. All right. It already has like my name and stuff like that. Okay, TCC patch that enables including files via HTTPS using curl. Great, just the patch. Okay, that was fun. That was a really fun exercise. It's pretty cool. So maybe somebody will pick it up, maybe contribute, maybe send to TCC developers, maybe somebody will, people will discuss that, maybe it will get somewhere, but that's an interesting concept, I think. Anyways, unfortunately, boys and girls, it is time for me to go. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you next time. I don't know what we're gonna be doing next time. We'll see. The winner gets tea, that's for sure. Check the description, check the links and stuff like that. And I gotta go. Love you.